Hello, welcome. Guys, today we're gonna cover our AWS topic on scaling our models and load balancing our architecture. So here we are gonna use elastic load balancing automatically distributes the incoming traffic across multiple Amazon EC2 instances. It enables us to achieve a fault tolerance in our application by seamlessly providing the required amount of load balancing capacity needed to route application traffic. We will also make use of autoscaling. Autoscaling helps you to improve application availability and allows you to scale your Amazon EC2 capacity out or in automatically according to the conditions you define. So for that, by the end of this demonstration of the lab, we will be able to create an Amazon machine image from a running instance and then create a load balancer, create and launch template and an auto scaling group, automatically scale new instance, create Amazon CloudWatch alarms, which will help all of this and monitor performance on your infrastructure. So to do that, we will have availability zone A and B with a public subnets and private subnet. So since we have two AZs, so we will have four subnets. So what we're gonna do is we'll create an auto scaling group in between, and this auto scaling group will be monitored by a security group, which is together application load balancer group, and that will monitor the RDS DB service or maybe the security group. So to do that, we'll what first create is the AWS AMI for auto scaling. So we'll navigate quickly to AWS Management Console and search for the service called EC2. In the instances, we will confirm that the instance is running. So we have instance into availability zones. Yeah, you see the web server is running and it displays 2 out of 2 checked. We'll select web server 1 and we'll choose create image. Okay, to create that, we'll create action, image and template, create image. So what does this mean? So if you can take a look here, we are creating an AMI out of that are applied when you launch an EC2 image. You'll create an image from the configuration of an existing instance. You'll give that image a name as in my lab server, and then we'll give an image description. And then what we'll do is we'll click on create image. A configuration banner pops up. You will see that this AMI when launching the auto scaling group later in this lab. So now what you see is current AMI status. Now what we'll do is we'll create a load balancer. To create a load balancer, we'll first create a target group, and then in that we'll create a load balancer that will balance the traffic across the multiple EC2. You see we have an AMI. Yeah, here close this. You should see this AMI. Now what we'll do is in in the left panel we'll choose target load balancer target group. First we'll create a target group. We'll create a target group, and for that will based on instance. We'll name the instance group name as, let's say, lab group, and then we'll choose next. We'll keep everything same. We just need the instances to be load balanced here. Uh, Before clicking on next, let me quickly check for the VPC. It should be lab VPC and click next. Okay, so you see that this gives me the number of instances there. I'll click next, and then the register target screen appears. Available instances, register targets. Targets are the individual instances that will respond to the request from the load balancer. We'll review the settings by clicking, and then in the left panel, we'll choose load balancer. Now, since we created the target, you see we have healthy status and everything in here. You can click here, you can see zero target. Zero target should not be the. Well, what we'll do is we will go back to the load balancer, and then we'll create a load balancer. In the load balancer network, what we'll do is we have three types of load balancer: application load balancer, then the network level load balancer, then the gateway load balancer. When you need to deploy and manage a fleet of third-party virtual appliances, it supports GNEVE. This application enables you to improve security, compliance, and policy control. For now, what we'll do is we'll select the application. Uh, for now, under load balancer name, under application load balancer, we'll choose load balancer type, application, load balancer name, we'll choose the application, like HTTP or something. And under scroll, and then we'll find the networking mapping. Under network mapping, what we'll do is for VPC, we'll again choose our environment, and then availability zones. Choose the first displayed availability zone, then select the public subnet from the subnet drop-down menu. Um, okay, and similarly, we will do it for the second. CIDR, choose public. The load balancer will be internet facing, so we will select both public subnets. The load balancer is internet facing. So choose the first displayed availability zone, which we did, this, and then we selected the public subnet. So we then we did it for the second one in the security group. What we will do is we will remove this, and instead we will select the web security. And there you go. From the listener, set the default action to forward. Listener put this as is, and forward to lab group. That is anything coming to port 80, forward it to this, scroll to the bottom, and then you can check with all of these features, and then you can do create load balancer. So that just creates our load balancer. You can view our load balancer by load balancers, action, click on it. There you go. This is choose view load balancers. Let's monitor. Now, see, this is our load balancer, but I do not see any traffic. It's still booting up, provisioning. I'll wait for it. And then now create a launch template and auto scaling group. To do that, this will only launch itself when there is a particular trigger happening. So what we'll do is we'll create a launch instance. We'll name that as a lab config. And under auto scaling guidance, we will select provide that. the application was, so there already should be a source template. Never mind. So application and OS image, application and OS image. So this is what we created. That's owned by me. And then the instance type, select as T2 micro, clear, and then we'll choose our keeper as key. We need a subnet, security rule, security. Now, under the detailed section, we want detailed cloud watch monitoring, and we will select enable. React quickly to the changing utilization. Once this is done, we have everything in place. We can create launch template. uh, choose success dialog. There you go. Auto scaling group. Let's create an auto scaling group. Auto scaling group. Let's name it as lab auto scaling group. And then launch template. And then just select next. Choose instance launch. That's the PC. Private channel. We choose attach an existing load balancer. Attached to an existing instance of the load balancer. Some target group. We created that target group. And now we will say enable health check. Okay, I'll click next. And then this is not required though. Enable group metrics. Monitoring. And let's say desired capacity is 2, minimum desired capacity 2, maximum capacity is 3. And let's name that security policy name reached by CPU utilization, target value to 60. And just give me the right attribute. Optional. So this is an optional field. We'll choose next. And SIP6 is also optional. You can have tags like add tag with name and then the value as something like that. Hope I don't have any space in front of it. Then I click next, gives me the detail, and select create scaling group. See, it instantly creates two instances. Minimum and desired is 2, maximum is 6. You can verify that load balancing is working by choosing the instance name. Lab instance, run it. Initiating source lab instance. There you go. And then on service, I choose EC2 auto scaling group. Install. Select S. And choose all action. Let's select this. and choose action, and target render to 50. Now let's watch what we see. Uh, let's navigate to CloudWatch. Let's see all alarms, insufficient data, CPU utilization is less than 50. Let's do a load test. Maybe there is some DNS issue, or the browser unable to perform this. Maybe as an incognito mode. I'm able to browse to the DNS URL and then continue to the site since it does not have the HTTPS sort. I will choose load test. The current CPU load is 100%. It should now show something as so in less than the 5 minutes, the alarm says low will turn to high. Check that. You should see the alarm high. So this is every 60 seconds to update the display. Alarm high. You got the trigger here. So doing this, there should be additional instances deployed. Let's see. If I go to instances, it's running. Let's see. It should come for more than 2 lab instances. It is just the matter of fact that our CloudWatch A load balancer. Oh, I see now. I see now. So this just triggered. So you should see some actions on EC2 instances. How do you do to the time constraint? I'm just trying to skip this, but yes, once you are trigger and the CloudWatch checks if this, for example, the monitoring tab, the CPU load, it is more than 50 or 60%, which we set as a trigger factor in CloudWatch, it will trigger the auto scaling group service for us. And to let you know what auto scaling we have used here, so in auto scaling group we are having this lab config. So what happens is we'll go to lab config and show you. So under lab config, we are using an AMI which deploys an EC2 instance. You see the lab config AMI, it deploys T2 micro. There you go. With the work key and stuff, you can have different attributes. You can see template, versioning, created by Wookie. That's how it is. And thank you, and see you once again in another session. Till then, take care.